What if the universe ends and no one notices? Our sight is bounded by horizons. This is not a flaw in our vision, but a fundamental law of reality. Light, the fastest messenger we know, is agonizingly slow on a cosmic scale. Space is wide, wider than we can truly comprehend. Because of this, the universe we see is a museum of the past. The light from the nearest star tells a story from 4 years ago. The Andromeda Galaxy appears as it was 2.5 million years in the past. The most distant objects we can observe are echoes from a universe in its infancy, over 13 billion years old. Far events, even cataclysmic ones, cannot send warnings in time for us to care. Their light is still on its way, a message in a bottle that may never reach a shore. We are forever looking at a ghost of what was, not what is. The most common stars in the universe, the red dwarfs, are masters of this quietude. They are the universe's paragons of patience. Unlike their massive, brilliant siblings who live fast and die young in spectacular supernova explosions, these faint stars sip their hydrogen fuel with miserly restraint. They can burn for trillions of years, far longer than the current age of the cosmos. Their end, when it finally comes, will be an anticlimax. They do not explode. They simply dim. Over eons, their fusion will falter. Their light will fade from red to infrared, and they will cool into darkness. For any civilization that might orbit such a star, there would be no single last sunset. Just a gradual, imperceptible chilling. A slow descent into a twilight that lasts for eternity. The remnants of stars like our own sun, the white dwarfs, follow a similar path into oblivion. These are the dense, hot cores of dead stars, glowing with leftover heat. They are cosmic embers, slowly radiating their final energy into the void. They cool like a forgotten campfire, but the timescale is staggering. Given unthinkable time, trillions upon trillions of years, their glow will fade through yellow, then orange, then red, until they emit no visible light at all. They will pass below notice, becoming hypothetical black dwarfs. Objects so cold, so dark, they are colder than memory, colder than the background radiation of the universe itself. They will be invisible ghosts of matter, adrift in the final dark. And what of the worlds themselves? Countless worlds drift without suns. Ejected from their stellar systems by gravitational chaos, these rogue planets wander the interstellar darkness alone. For any life that might have clung to their surfaces, the end is not a fiery apocalypse, but a deep, encroaching cold. They feel night thicken, not as a ceremony, but as a simple physical reality. The faint, distant starlight offers no warmth. It is just a little less warmth from its dying parent star, then less, then none. The atmosphere freezes, falling as snow onto a silent, barren landscape. The final end is a quiet frost, locking the world in a tomb of ice. Rarely, in the deepening gloom, these stellar remnants meet. Two white dwarfs, or neutron stars, spiraling toward each other for billions of years, finally touch. The result is a crush of gravity, a brief, violent flare of energy, a kilonova, or a Type 1a supernova, a final defiant shout against the encroaching silence. For a moment, a small patch of the universe is illuminated with the light of a billion suns, but it is fleeting. The dark resumes, deeper and more profound for the contrast. These are the last fireworks, beautiful and pointless, in an otherwise empty hall. On a grander scale, entire galaxies grow tired. The vibrant, star-forming nebulae, the cosmic nurseries that birth new suns, will exhaust their reserves of gas. The beautiful spiral arms, defined by the bright blue light of young, massive stars, will loosen and fade. Star-making, the engine of galactic life, slows from a roar to a murmur, and then to nothing. The galaxy's light becomes redder, older, dominated by the long-lived dim red dwarfs. No alarms are sounded. There is no galactic death rattle, only the pervasive hush of spent fuel and fading light. The great cosmic cities become ghost towns. In this far future, gravity's last architects are black holes. They are the universe's final collectors, sweeping up the cold, dead remnants of stars and planets. Over unimaginable timescales, they will be the only significant objects left. And they too will merge. When two black holes spiral together, they do so in silence to most observers. The cataclysm releases more energy than all the stars in the observable universe combined, but it is released as gravitational waves, ripples in the fabric of space-time itself. For a hypothetical observer watching from afar, there would be no flash of light, no explosion, just a momentary bizarre warping of the background stars, a flicker of curved light, and then a deeper, more perfect absence, where two shadows became one. But even black holes are not eternal. They also leak. This is the strange prediction of Hawking radiation, a whisper of quantum mechanics at the edge of the abyss. At the event horizon, pairs of virtual particles are constantly popping into and out of existence. Occasionally, one particle falls in while the other escapes, carrying away a tiny fraction of the black hole's mass. The process is impossibly slow. For a solar mass black hole, it would take 10 to the power of 67 years to evaporate. This is a number so large that within any conceivable lifetime, within the entire age of the universe so far, it is indistinguishable from perfect stillness. The giants go last. The supermassive black holes at the centers of galaxies, billions of times the mass of our sun, will hold out for incomprehensible lengths of time. An age so long it is called a Google year, 10 to the power of 100. But even they are not forever. After ages beyond counting, their evaporation will accelerate. In their final moments, a supermassive horizon thins and its temperature rises, releasing its remaining energy in a soft, ghostly glow of high-energy particles. And then, in a final quiet pop, it is gone. The last great structures in the universe vanish not with a bang, but with a faint, final sigh. With the black holes gone, what is left? Only scattered particles in an ever-expanding void. And perhaps even these are not permanent. Some theories of grand unification suggest that protons, the very building blocks of atomic nuclei, are unstable. Perhaps protons decay. If so, over timescales that make black hole evaporation seem swift, matter itself unties its own knots. The last cold embers of black dwarfs and rogue planets would quietly dissolve, atoms loosening their bonds, their constituent particles transforming into light and other fundamental particles. It would not be a bang, but a slow collective withdrawal, the final quiet surrender of matter itself, or perhaps not. If protons are stable, then matter will persist. Then, in the absolute cold and dark, quantum mechanics offers one last strange possibility. Through the bizarre magic of quantum tunneling, the atoms within the cold, dead black dwarfs could slowly rearrange themselves. Over truly astronomical timescales, fusion could begin again, not through heat and pressure, but through sheer probability. These hypothetical iron stars might glimmer once, a brief ghostly spark in the infinite night, before collapsing into neutron stars or black holes, surrendering at last to perfect, unending dark. This is the beginning of the dark era. It is not a sudden curtain drop. It is a room where the lights were slowly dimmed over trillions of years, until all that is left is a vast, cold, and nearly empty space. Only thin, low-energy whispers remain, stray photons with wavelengths longer than galaxies, elusive neutrinos, and perhaps the faint hum of gravitational waves from long-ago mergers, all stretched and diluted by cosmic expansion into near-nothingness. This is the state of maximum entropy, the so-called heat death of the universe. Entropy, the universe's tendency towards disorder, finally wins. It evens out all the temperatures, smoothing away every gradient. With no free energy left to drive them, all meaningful processes stall. Change itself ceases. Nothing new announces its arrival, because nothing new can ever begin. The end is not an event, it is the cessation of events. Yet there are other, more sudden possibilities. Some theories allow for a catastrophic vacuum decay. The vacuum of space-time itself might not be in its most stable state. It could be a false vacuum, a temporary state with trapped energy. If a bubble of true, lower-energy vacuum were to spontaneously appear anywhere in the cosmos, it would expand at the speed of light, rewriting the laws of physics as it goes. There would be no sign, no siren. For anyone in its path, the end would be instantaneous and absolute. The universe wouldn't end, it would just become something else, instantly. Or the fabric of space-time itself could pull apart. If the mysterious dark energy that drives cosmic expansion grows stronger over time, it could lead to a big rip. This ending feels gradual at first. Distant galaxies would vanish from sight faster and faster. Then, the pull would overcome gravity, unbinding galactic clusters, then galaxies themselves. In the final moments, it would tear apart solar systems, stars, planets, and finally, the atoms and nuclei within us. Locally, it would feel like a slow, inexorable stretching. Things would simply drift apart, then fail. Ultimately, endings are about where you stand. For most observers in our accelerating universe, the end is not a singular event, but a process of isolation. As expansion speeds up, galaxies are carried away from us faster than their light can reach us. They cross a cosmic horizon and vanish from our sky, one by one. The universe ends as a shrinking horizon, a quieting, emptying field of stars, until only our own local, gravitationally bound group remains, an island in an endless, unobservable void. We live on human scales. Our lives are flashes of lightning in a slow, geological afternoon. Our civilizations are campfires that burn for a night on the shore of a cosmic ocean. They will fade long before the stars do. Memory ends first. The stories we tell, the knowledge we gather, the very concept of a past and future, these are fragile. They will vanish long before the last red dwarf cools. The sky will follow, but slowly, on a schedule we are not equipped to witness. So the universe might end without anyone noticing. Because by the time the real end comes, there will be no one left to notice. The stage will be empty, the lights will dim, and there will be no applause. This quiet, unnoticed end is not a tragedy to be feared. It is a reminder of the sheer, improbable luck of this moment, a moment of warmth, of light, of consciousness, a moment to see the stars before they fade. Notice now,